So before we start talking about writing formulas and bonding and all these stuff, we need to review two important points. First of all, we need to look at the location of metals and non-metals in the periodic table. And as you can see, metals are located in group 1, group 2, and aluminum, for instance, is in group 3. You will also know that non-metals are located in the rest of the groups in the periodic table, which is group 14, 15, 16, and 17. And for group 18, the last group here, you can find the noble gases, and we're going to talk about noble gases shortly. Also, metals are located here in the middle of the periodic table, and these are the transition metals, and we're not gonna discuss transition metals this year. Okay, so I need also to remind you that hydrogen is not a metal and that it is not an element of group 1, so it's just put here because it has only one electron in the outermost. Okay, another thing that I need to remind you of is the shells and how many electrons will fill every shell. So as you can see here, the first shell holds a maximum of 2 electrons, the second can hold a maximum of 8 electrons, and the third shell holds a maximum of 8 electrons. The number of electrons in the outermost shell will determine which group the element is going to be put in, and the number of shells will determine which period. And if you want to review this, or if you don't understand or don't remember this part, you can see the previous, you can watch the previous video. Okay, so we're gonna get to a point where we have to say that the filled electron shells are very stable. So whenever you have a filled electron shell, like in this example where the first shell is filled with 2 electrons, the second is filled with 8, and the third is also filled with 8, this is a very stable electronic configuration. But not all the elements have all the shells filled with electrons. So in order for an atom to become stable, it has to have a filled outermost shell, because mostly the outermost shell is the shell that lacks electrons. So usually elements, they don't stay like they are. You cannot find elements in around you, only elements around you. Like for instance, you will never see sodium on its own. You will find, for instance, sodium chloride, which is a compound, but you will not find sodium. Sodium will not stay as it is. Okay, so usually you won't be able to find these elements. Not all the elements are able to exist like elements without forming compounds, and most of the elements, they form compounds, and you can see compounds all around us. You can see, for instance, this is one compound, which is carbon dioxide. You can see also water is a compound that you can see. Sodium chloride, which is the table salt, is also a compound. It's formed from sodium and chlorine. So elements, they usually react together to form these compounds. So it is really important to know exactly how these elements react to form these compounds, and also how to write the formula of these different compounds. Okay, so let's look at some forms of elements, which are the noble gases. And the noble gases are different from all the rest of the elements in the periodic table, because if you look at noble gases in the periodic table, let's take a look at noble gases in the periodic table, you will find that all the noble gases, they have filled outermost shells. Like for instance, helium, because it has only one shell, then this shell can be filled by 2, and helium already has this shell filled. For neon, it has 8 electrons in the outermost. For argon, also 8 electrons in the outermost. So all the shells of the noble gases are filled actually with electrons, and all the elements, they want to do like noble gases, and this is why you can call them noble gases. They are noble. They don't want anyone. They are better than everyone, and each one is looking at noble gases and hopes that he can achieve the noble gas configuration. And when I'm talking about the noble gas configuration, we have to mention this rule, which is the octet rule. So octet rule says that atoms, they tend to gain, lose, or share electrons so as to have 8 electrons in the outermost. So it depends on the element. Some elements may lose electrons from the outermost shell. Some elements may gain electrons. What is most important here is that an element have filled outermost electrons. Okay, so if you look here at potassium, and potassium has the atomic number 19, you will find that potassium has in its outermost shell only 1 electron. So if potassium loses this electron, then its outermost shell will have an 8, because it will lose this outermost shell, and the outermost shell will be the third one, and the third one is already filled with 8. So potassium, if potassium will form a certain compound or will enter into a certain chemical reaction, the first thing that potassium will do is to lose this electron. As for nitrogen, nitrogen has 5 electrons in the outermost, so nitrogen will tend to gain electrons. Nitrogen will gain 3 electrons to have 8 electrons in the outermost. And for oxygen here, it has 6 electrons in the outermost. Then oxygen will tend to gain 2 electrons to have 8 electrons in the outermost. Okay, so actually the formation of compounds, and of course the type of compounds that we're studying now, which are called ionic compounds, they involve the transfer of electrons between atoms. So here sodium atom will lose 1 electron, chlorine atom will gain this electron from sodium, and this will lead to the formation of what we're gonna call ion. And if you refer to the video where I was using the PhET simulation to describe atoms, you will also know more about ions. So ions, they get formed from the loss and gain of electrons from an atom. So sodium here, because it has lost 1 electron, it became a positive ion, and chlorine, since it gained 1 electron, it becomes a negative ion. A positive ion and a negative ion, since they have opposite charges, they will attract, forming a bond. Okay, so this is sodium chloride, and sodium chloride is the table salt that we're putting on our foods.